Right guys, Cam here, battling away in the workshop. I had quite a few requests to show a little bit more in depth this slaughter. So I'm going to do a strip down of the slaughter. I'll show you how it's put together. But before we do, I thought we might actually cut a keyway with it, so you can actually see it being used as it's designed to be used. So we'll just kick it off. Just a very slow stroke, we'll just get things started first. Stick a bit of go juice on there. Now this is a 3/16 key bit, slotting bit that we're using to cut a 3/16 key one. Now I have cut up to a 6mm wide keyway before. I've got an arbor to fill that in. And the maximum, or the biggest keyway I have slotted in here is 10mm, and that's with side cutting on that 6mm bit. So you can probably hear from that it's a pretty smooth action. It's a really handy little unit. Oh, trying to get it focused, but there we go. I'll try and stay out of the way of this. I must admit, I prefer cutting a keyway in a slotting arrangement rather than a shaping arrangement. It's nice to have gravity working for you with your setup. And you mount this on a rotary table and cut splines or multiple keyways. Just go 3mm depth on that. It's a little bit oversized, but I'll show you what it looks like. Alright, we'll let that ramp out at that. Righto, so I've got my digi-read up out here, and at the back there I've got one of the Chinese high-win variable speed drives, VFDs. That cost me about $120 delivered, I think. Just got to get through the Chinglish to try and understand how to program it, but once you sort of get your head around it, it's great, and it's great to be able to do speed control for doing slotting operations. Ideal. So on this mill, when I got it, it's not actually a Bridgeport, although it does have a Bridgeport head on it. It's actually a round tower. They're made in Taiwan, and same with the base. So I've made up a spacer ring, 50mm spacer ring, to get the head up a little bit higher, and I've made up a new nut stand and a new nut, and cut a new screw for the raise and lower. So that particular nut stand is approximately 100mm shorter than what the existing was, and that allows me to drop this knee down almost into the drip tray. I've actually raised it up by 2 inches as well, so that's given me extra stroke in that knee so that I can fit my rotary table with a 3-jaw chuck and still have plenty of throat room. a lot of the slotters I've seen, by the time you get a rotary table on there and a chuck, you've got virtually no throat room to work with. So the way I've got this set up now, I've got tons. So very, very happy with the way that's turned out. Now, I want to mention in the other video, this has an infinitely variable stroke adjuster from 25mm up to 76mm. The longer the stroke, at a certain point I need to take the pivot point out from here and pop it into here to allow that a longer stroke to occur. So in other words, the ram can go further into the slide arrangement. So there's two positions there that you need to be aware of when you're modifying your stroke if you're going probably beyond the 60mm mark. As I said, it's just a Gem Power head that I've modified. It still acts as a standard horizontal head when you take the sliding attachment off. It's just had to do some machining on there to set up registers to get that to align in. One thing I do with any design, with anything I manufacture, lubrication, and lubrication. There's so many failures of mechanical gear because it isn't lubricated correctly. So these all have gullyways through them to feed the slides. They're high density plastic. That's what I've used for the slideways, and that works really, really well. So the galleyways run all the way around. Get around that and have a look. So before each operation, I oil the whole show right up, and you may see, there's another oil hole in there for the base of that crank. Righto, so that's the head running. So what we might do is stop this, and we'll take the head over to the bench and we'll strip it down and show you what it looks like inside. Alright guys, we'll see how we go with this with the camera in the way. So this is the Gem Power unit. That's a right angle drive unit that I've modified to fit this this slotted body on. So slotted body has two functions. Inside here we have a swash plate or a cam plate, which is directly attached into the nose of this 90-degree unit, and we've got the main body that houses the slotting ram. So we've got rotary motion being controlled by the nose. We've got a solid fixed body onto the Gem Power unit, which is attached to our ram, which is our reciprocating motion. So let's strip this down a little bit. So on the back here, just to get it nice and tight and pull this body right in, because rigidity is really important with this sort of attachments, I've got this strong back, which is once again located, machine located on the back of the Gem Power unit. What I've also done is I've made a setting block, and that's very critical. So it's got a machine register into the Gem Power unit at the back here to get the alignment in this direction. So what I did was, when I set this up in the milling machine, and I pre-trammed the head very accurately, ran a dial indicator up and down the ram, and just took a little bit off at a time, just ground a little bit off that face at a time, until when I put it on there, bolted it all up nice and tight, I was within, it was less than a thou, total misalignment. So yeah, very happy with that. Matter of fact, I did go a little bit too far. I had to build it up with some weld and then start machining it back again, but yeah, one of those things. So I've got those little tie rods in there, pulling that strong back nice and tight. I'm probably going to go in and out of frame here a little bit while we actually strip this down. And with these units, rigidity is critical. If you don't have rigidity, you get all sorts of vibration and you get very poor finishes and a very poor result. So it's beefed up quite considerably. If I can get this off, I'll be right. So you can see that first registered face that I've machined on that gem power unit. So the angularity in this direction was taken out by the set block. The angularity in this direction I clocked up, locked in place, and then machined and fitted these shoulder screws. Well, some people call them dowel screws, but they're actually called shoulder screws. They're an Umbraco shoulder screws, so they actually have a dowel shank on them. So they're ideal for doing alignments and fastening. I apologise if I keep going in and out of shot on this, but I'll see how we go. Right, so we've got those released off. So with those shoulder screws, you can see they've got a dowel body which registers into the gem body itself, so you get that alignment. So once again, as I said, I clocked this up, rotate this around, clocked this up, got it in position, locked it in place with the strong back and those tie rods, and then drilled through, doweled and tapped. And I've got a lot of pictures of this build that I did, so at the end of the video I'll actually put a series of the photos up. But I found it on an old drive, an old computer that had died, but whenever old computers die, I take the drives out, because you never know what you might have missed. So I did find those off file. So we'll just take this slaughter body off. Before I do, one of the other criticalities I had in this design was to try and make this as compact and as squat as I can. I wanted to, where the load is being applied, it's going to be applying a moment. So the further out you go, the higher that moment, the more the force that's going to be on the quill. So I wanted to try and keep that back in as compact as I possibly could, and I certainly achieved that. I've got no room in here whatsoever. And it can be a little bit awkward to get off, so just bear with me. I'll tell you what I haven't done. I haven't taken the drill bolt out, so we better do that. You can sort of see that I have to snap that because the ram is going up and down. Alright. So this is actually an ISO 30 taper in here. When you split it down, you'll see I don't actually use the taper at all to locate this in. So I'll take that drill bolt out. Not exactly engineered, galvanised from Bunnings, nice and cheap. Right, let's see how we go this time. Right, let's get everything unlined up here so we can see. So that's the gem power unit. It's actually a not quite a 2-to-1 ratio with the bevel gears that are inside this, but on that gem power unit, you can see I've machined this face back, and I've actually machined that as a register. Now inside here we have this swash plate, or cam plate if you like, and that register on that cam plate registers on the OD of that spindle. And we've got the slots inside here that you can see that register onto these drive dogs, these keys here. So I've got no bearings inside this whatsoever. So this basically, when it's loose, it just flops around inside it. The alignment occurs once that is engaged, and you've got that diameter there engaged on that diameter there. That centralizes everything. So no bearings in this whatsoever, and that was done to try and make that as squat as we possibly could. So we're using the bearing sets that are actually a part of that right angle drive. Now the variable stroke, if you like, is achieved with this fella here. So you can see inside there's a slot. I'll bring you this one up, because this is the other swash plate I use for the horizontal attachment. So you can see that slot there. So as we moved this socket-headed cap screw that's been modified is attached onto the actual crank arm. So as we move that out, the greater the stroke. As we move it in, the less the stroke. So I've sort of set that halfway, but that is variable, but you have to vary that or adjust that before you actually put it together. So I've sort of struck a bit of a sweet spot where I'm comfortable with this. It's about halfway on there, and then that's locked up, and you know, it's about 50 millimeters a stroke, I think. You can see that set block that's sitting in there, the way that's set up to register on that face there to keep that dead square in that direction. Alright, well, let's strip this down a little bit further and we'll show you what's inside. So we'll take the face plate off. We've got to release off that ram as well. So let's make a start with that. And this thing is all doweled together as well. So whenever you're doing tool making, precision tool making, you want stuff to go back the same way repeatedly. It's important you put some sort of registering system in place, whether that's a dowel or keys or something. It's been a long time since I've actually had this off, so just have to bear with me a little bit here. I sort of hope I'm somewhere in frame there for you. And I also think from memory that I've got some screws that go down into that, so I've got to take this front cover off as well to get access to those. You might notice too that I've got full adjustments on those bearing slides in there, on the front face and also on the side face. So once again, rigidity is key on this. You've got to try and get them up as tight as you possibly can to minimise any vibration issues in that ram. Once again, as I mentioned before, any design, you've really got to consider your lubrication. So I have lubrication points all over this fella. Unfortunately, with this, I've actually had this top part apart. I'm designing up another slotting head that's a powered slotting head, motorised slotting head, just a very small unit to mount on the saddle of a lathe. So at the end of this we might show you that model. And I've started doing all the detailed sheets for that at the moment. A lot of compromises when you're designing stuff, and you've got to pick the best compromise. Obviously the functionality is the most critical thing on anything, and that's primary. And you look at manufacturing, the ability to actually manufacture it, and you look at the maintenance. How is it going to be maintained? How is it going to be stripped down? Alright, so I've got these big socket-headed cap screws in here. Now if I take those off, we should be right.
Sorry about this, we're sort of working in a fairly limited space. I might take that little gen right angle unit out of the way. We'll come back and have a bit more of a look at that later on. I've had to do some fairly different things to try and get all this to pull in nice and squat. Sometimes you've got to think outside the box a little bit when you're doing machine design. You really got to think it when you're doing special machine design, looking at it in 4 dimensions. And the important thing is it seems to get lost is maintainability. When a piece of gear goes into a process line or wherever it goes, you've got to make sure that you make it as easy to maintain and strip down when there are issues with it. Right, we'll get this little bloke here off. So release that pivot. One thing I didn't mention is I actually have a shear point here. I've actually got to reduce it. I stuffed up with the numbers. I've redone the shear calcs on this based on the force of the cut, and I've got to reduce that back to around about 2.5mm diameter. That at the moment is about 5mm. So it's important if you hit something and you're going to damage something, the bit you want to damage is the bit that you've designed to be damaged. In this case here, it's a shear pin. So whenever you're designing, you always look at what is going to be the failure point. And 9 times out of 10, you'll try and design to meet motor capacity. So you'll stall the motor out and trip the motor out before you do any damage to plant or equipment. Sometimes you can't. You've got to use, shear pin type arrangements or torque limiters or other devices to try and minimise any damage that may occur or stop any damage that may occur if there's a failure. Alright, I'll just strip that down a little bit further. Right, so, like I said, it's been a while since I've actually stripped this down, so you'll have to bear with me a little bit here. Let's try and get this. So I might just back those. Back off those slide weight. We'll loosen this off a little bit. I'll show you what they look like when we get this apart. Get those backed off a little bit. Give that a bit of a tap to get in there. Okay, so that's our ram out. I put the 2 positions here. As I lengthen the stroke, I need to move this up so that it's not going to hammer into the slideway. So gives a bit more stroke on that ram, keeps it out of the way. But yeah, nothing flash on that. I've just got the, if you like, the tool holder mounted up inside this. I've got a grub screw so I can take those out and put different types of holders in place if I need to. You can see, I take that out, you can see that's just flipping around inside. It's a neat sort of a fit, but it is a clearance fit to it. So that's why we need the nose of that gem unit to register that, pick that up. And the outside diameter here gets picked up on the nose of the gem unit, which does the full alignment on it. Right, we'll see if we can't get this off now. Actually, one of the things I did design in this, and I must admit, is I put jacking screws. Whenever you've got tight fitting stuff, always try and design a methodology where you can remove it easily. And jacking screws are the ideal way on these sort of particular faces. Always give the fitter something to work with. They're often down a deep dark hole underneath some gear and trying to work on stuff. Great if it's in a machine shop or a workshop and you've got a plethora of room to work in, but when you actually get down on a site, some of the conditions you've got to work in to get the job done, these little things just make things so much easier. So always consider maintenance whenever you're designing anything. Right. So there we go. I'll take those out of the way. The ones will fall out of the way. Oh, they're going to be trapped in there, that's alright. Right, so you can see the slideway. I should have gone through that. So I've just got this held in with little tiny socket-headed cap screws. I think they're M3s actually. That lock the fixed slides into place. And obviously the floating slides that do float over the top of that. I've got. I might try and get one of those out and show you the buttons that I've got inside there. Just bear with me for a minute. I'll try and get stuff out of my cupboard here without knocking it into pieces. Right, so let's have a look up inside there if we can. Now, you can see the button heads that I've got that press onto that slideway that take up the slop. What I've also got, so I didn't want the oil going in the back here, I actually want the oil going where it's supposed to go, so I've got a little tiny copper tube that I've put in there that picks up on the oilway hole that feeds the oil in there. And these are all cut. This particular one's cut through to allow oil to get down to the base one. So I've tried to make it so oil can flow right around the perimeter of this slideway. So there's a multi-part arrangement. So we've got the sides, if you like, of that slideway support, and they are a keyed fit into a groove that I've milled into here. Keyed in and then bolted through. Matter of fact, that bolt obviously picks up and also locks it onto the main body as well. So I hope you can sort of see all that fairly well. Righto, so here's our swatch plate. You can sort of see that wobbling around. You can see our crank. This is all sized up so that's minimal slop in this. So I've got shims or shim washers, if you like, that I've machined to when I lock up this fella here. We've still got that rotational movement in there, and you can have a look. I've actually got, hopefully you can see, I've got an oil hole in here feeding that bottom bearing, and these are just Delrin bearings, the acetal plastics. And same up here. Once again, we've got a small oil hole to feed that the plain bearing in there. And as you can see, everything's dowelled. I've actually used sellock pins or roll pins to get everything lined up and fit it off properly. So that's it stripped down. It's fairly basic. Obviously, we've got the slot in here to allow the crank arm to operate, but inside here there is absolutely minimal clearance for everything. Everything is as squat as I can possibly make it. And while we're here too, that's our keyway we cut, and they come up beautiful. So it's exactly what we want to see. This is the swash plate, as I said, I use for that the horizontal attachment that I've got. I'll go and fix that in a minute, but these diameters are different, but basically you can see that it's getting a bit crowded here, but the idea is that that will come in and register perfectly on there. And then onto that, we've got our crank arm that gets attached. So I actually got a bit slack. I was going to manufacture another head to go on here, but I just made them interchangeable. So basically this unit here can go directly onto here and mount up. And that's the swash plate that goes down inside. And once again, that swash plate that's all the same dimensions as what that gem power unit that's allows that to slide up, and that fits up onto the quill of the actual milling machine. The quill, the drive quill, can go down inside, and once again, as I said, that engages onto that diameter there and picks up those drive dogs to actually impose the motion through it. So that's a fairly quick breakdown of what this is. What I might do is I'll take you into the office here, and I'll just load up the CAD and show you how I go about some of this design work on these things. So when I'm designing at home, I do things quite a bit differently. So it's very, very quick and rapid, and it's just an idea of throwing ideas down and developing something from those ideas, and then refining it as you go to meet the criteria that you want. Obviously compactness on this particular unit was critical, and rigidity was also critical. So I'll shut it down, and we'll go and have a look. One other thing too, I should have mentioned too, that when you pull these things apart, you don't know which way they always go together. So I always witness everything, so that everything lines up and you put it back exactly the way that it came apart. So witnessing is critical, absolutely critical. All right, I'll go and have a look in the office, and we'll load up that CAD file, and we'll have a quick look at that. Right, so here we are in the office. I hope this is going to show up all right. But basically, you'll put down all the envelope dimensions of your known pieces of gear, like the gem unit. You'll measure that up and put that down as a known, and then from that you'll start developing how you're going to attach your various elements into that, and look at how you're going to get that thing up as squat as you can. So I tend to throw my ideas down. If they don't work, I throw them off to one side, come back, modify them, rework them, and as you go through this snail trail, you slowly start developing up something that's going to start working for you. And once you're at that stage and you're happy, I just very, very quickly throw details up and start dimensioning stuff up, and basically use this like a palette. So it's very, very rough. It's just, I just throw my ideas down, get the concepts right, get things working on the screen. I did this quite a number of years ago, this particular one. I tend to use I tend to model in 3D now. It's much easier to get that full all-round feel to it. But back in the old days, this is how I used to do it. And as I said, this is how I did it at home. This is totally different to what you do in a work situation. And it's great because even on the fly, when you're at the machine shop, you'll start, and there's a swash plate, you'll start modifying stuff as you go through. And you just throw your ideas down, work the problems, come up with your solutions, develop it into something that's going to be workable, and then detail it out. And then head out to the workshop and do the fun stuff. So there's my long-suffering, very old 2005 AutoCAD light that I do have fairly souped up. And yes, it is legal. Very expensive to buy this stuff now, and yeah, just can't afford it. It's not worth it. So yeah, that's basically how I go about design. Just get a bit of a palette down and just start throwing things together. All right.
So what I might do now is I'll put a series of photos up of the actual build of this unit as we went through it, and what I might do then is show you the design I've put together for this slotting head that can mount on the saddle of a lathe, and it can also mount on the table of your milling machine and set up with a dividing head so that you can slot into that and able to traverse it as well. So I've got a little slide arrangement that will mount with that as well. So, and I've made the if you like the ram head variable, so you can mount it on, I think it's a minimum 320mm swing lathe, and you can vary that up infinitely, and you can put packers underneath it if you wanted to get up to the next size. But I think I've given a stroke of around about 50mm, I think, and that also gives you the capacity to actually side cut as well. So it's a little motorised unit. I've got about a 0.18 kilowatt motor that's going to mount on that, driving through a worm and worm wheel arrangement, and I use what I like to term cartridge design. So if I get that together, we'll have a look at that model, and we'll break that down, and we might make that into a little workshop project we might work through. We'll see how we go. Alright guys, well, I'll throw some photos up of this build when I was doing it, and we'll try and get some models together for that slutter head that I've modelled out. Alright guys, before we actually have a look at the photos that I put together of the slotting attachment, I thought I might just show you a little bit of the specialist gear that I've made in my workshop, just to extend the capacity of my machinery. So this is my my faceplate that I machined up. I actually machined this up in the lathe just in front of me here. This is a fully fabricated unit. What I'll try and do, I'll turn it around. So I fully fabricated this this faceplate. I tried to look for one that was reasonably inexpensive, but they were well over $1,500. So yeah, I ended up fabricating this one. As I said, I machined this one up in my lathe. And that's my big 4-jaw. That measures about, oh gosh, it's about 1/2 metre in diameter, the big 4-jaw, and the faceplate measures, I think it's about 630mm in diameter, that one. So I have machined some pretty big stuff in that, but as I said, I did machine the faceplate fully on my lathe. And this is another thing I machined up as a spacer for the bridge port. There's a 5-inch spacer, so I had the ring, or the body of this rolled in a fabrication shop, and I had some 25mm plate that I actually hacked the pieces to get the fit, so it's all been welded up. You can actually see the seam weld in there. So yeah, I actually machined that up in the lathe as well. So that's about, what's that, 390mm in diameter, I think. So that's some of the bigger gear that I use in my lathe, and I've actually swung 700mm in this lathe, so and machined. So yeah, it's a little high power, made by the Xingshang or the Goshan Machine Works as it is now. It's only a short bed. It's only an 800mm bed on this one, so it's not a big bed, but it does everything I wanted to do. I think I might have showed it one other time, but that's the 50mm spacer ring that I machined up just to lift that head up as well. But as I said, I can put the 5-inch one in there, or I can double them up and make it a total of 7 inches if I wanted to lift that head up any further. I do have something a little bit unique, and that's an overhead crane. So we've got no trucks on this. It's a total swinging arrangement that mounts basically, or swings on a ball bearing, as in the actual ball. And it's pretty hard to see, but as you move it, as you move one side, the other side decides to catch up, and away it goes. So it's totally flexible and actually extends in length. And I'll pull that one back. So it's an extremely compact little design. And believe it or not, off this I've actually listed 200 kilo. So it's a great little overhead crane. And very, very compact for tiny workshops. So something I need as I get older, because when I'm trying to lift this sort of stuff up into the lathe to mount it, it's you just can't do it by hand. You've got to have something to lift it. So hence the little crane comes in really handy. Alright, we'll see how this is going to look. I'll just grab my son's laptop. He's got a student copy of this program. Alright. So that's the unit there, and as I said, it's going to mount directly on top of the saddle of the of my lathe. It's fairly straightforward. As I said, I think it's a 1.87 or 0.187 kilowatt motor driving down through a worm and worm wheel arrangement, driving the ram backwards and forwards.
I haven't got this constrained up properly yet. And the slider, as I said, we can move this up and down depending on the center height of your lathe and whether you want a side cut as well. And then we can lock that off into position. So I'm thinking of maybe just using a dial indicator on here, just coming down one of these faces here, so you can work out how far you want to move it up or down or side cut it. It's coming around to the rear end, so that cartridge bearing arrangement, which also supports the worm wheel. I've got that set up to also mount off and support the adjustment for the motor for the belt tension. And so we're just using a standard tooth belt for that. That's how we're going to drive that. So as I said, it's very, very compact. Measurement wise, it's about 200 wide. Yeah, 200 wide, and it's 190 long. And I think height wise, it's just shy of 300. So it's not an overly big unit. And as I said to you, that I'm going to put slideways in here and come up with a slide arrangement that we can mount with a screw through here. We can mount this actually on the bed of a milling machine. The dividing head at the other end, you can actually act it like a shaper. So we'll see how that goes. So that adjustment up and down is done with that hand wheel there. And as I said, we can then lock off that gib to lock that in place. And then, as I said, we can do incremental side cutting of that if we need. And I've got it so that we can actually adjust it into 3 different stroke positions. So I'll just lift this flat up out of the way. The way that you access that through these hole or through this hole here, but let's come around. That's the problem when you've got these here computers. We'll get it to there. We'll just move this up out of the way. Alright, so we can access this fella here to adjust the position in 3 positions, and that'll adjust that stroke. And here, once again, I've got lubrication points all over that. I've seen some absolute disastrous results because designers haven't considered lubrication and the type of lubrication and the method of delivery of the lubrication. So yeah, so very compact, as I said. Everything I've designed off this, I've actually been able to purchase off eBay. So the main body is just a big section of rectangular hollow section. The other stuff's just mainly billet type stuff, so there's no rocket science in it. So as I said, we might make this as a little workshop project, and yeah, we'll see how it goes. I love the idea of being able to slot in the lathe, because I've got a full indexing system on the back of my lathe. If you want to slot stuff, you've obviously turned the stuff in the lathe while it's sitting in there. After you've turned it, it'd be great to just plonk that down in the saddle, bolt it up and slot a keyway in it, or slot a spline in it, or whatever you want to do with it. So that's where the inspiration for this one came from. So it was actually a guy called, I was looking on the on YouTube, I think it was a guy called Merv Harris, who had a slotting attachment that he made up for his lathe. And what I saw from his lathe, I thought, what a great idea. So we basically compacted it and basically taken the idea that I saw on Merv's site and turned it into this. So in design, if you don't have to reinvent stuff, if you can go off other people's ideas and come up and come up with something and not reinvent the wheel, it makes life so much easier. And as I said, I saw this one on it's Merv Harris, I think he's called, and yeah, I thought, what a great idea. Let's try and do something with that. So that's what we've come up with.
Alright guys, we'll leave it at that, and we'll come back with a lot more soon, hopefully.